So today we'll discuss about the resonance. In resonance, we are having some condition based on this. What is the first condition of the resonance? Yeah, first, according to the pattern I'm telling you, okay? So for resonance, there is a condition that XL must be equal to the XC. Okay, and you know what is XL? XL is the inductive reactance, correct? And what is XC? XC is the capacitive reactance. And you know the formula for the XL as well as for the XC. XL is how much? There is 2 pi FL. But for the case of resonance, frequency is different. Okay, for the case of resonance, frequency is different, so I'm considering it as FR. What does FR means? FR is the resonant frequency. FR is the resonant frequency. And what is XC? XC is equal to 1 by 2 pi FRC, correct? So if we'll solve this equation and will get the value of FR from that, can you tell me what would be the value for FR in this case? If we'll go FR will go on this side, then it would be FR square, right? It would be 1 by 4 pi square. For FR square, it would be 1 by 4 pi square. It would be LC. If we'll solve completely, then we'll get FR is equal to 1 by 2 pi root LC. That is the frequency. And which frequency it is? It is known as the resonant frequency. Okay, so for resonance, we are having one condition, that is XL equal to XC. From that, we derive that FR value, resonant frequency, that is different from the normal frequency. That is how much? 1 by 2 pi root LC. Okay, so this is one condition. If I'll put the XL equal to XC in Z formula, what is the formula for the impedance? Formula for the impedance is how much? That is root of R square plus XL minus XC whole square, correct? If I'll put the value XL is equal to XC, then tell me what would be the value of Z in this case? Z value would be equal to, tell me, if XL is equal to XC, then Z value would be equal to R, correct? And you know that in the case of resistance, the phase angle is always 0. In case of, because now it behaves like a resistive load if XL equal to XC, and in case of resistive load, phase angle is 0. What is phase angle? That is the angle between voltage and current, correct? So if phase angle is 0, then cos 0 is how much? 1. Cos 0 is how much? 1. So in the case of resonance, power factor is always what? Unity. Power factor is always unity. So we'll conclude what? That in the case of resonance, XL is equal to XC and FR is equal to 1 by 2 pi root LC. That you need to remember this formula in for the purpose of numerical, and Z value is equal to R. Okay, up to here any doubt? So we are having these values for the resonance condition. So based on this graph, we'll draw, based on these values, we'll draw graph. If they'll say that derive series resonance, this one I'm talking about which resonance? This one is the series resonance. Okay. If they'll ask to you that derive series resonance, then you need to draw the graph for that as well. Okay, now see how can you draw the graph. Now tell me for one thing first, if Z is equal to R, then Z is minimum or maximum according to you? Earlier, yeah, earlier because the Z value was root of R square plus XL minus XC whole square, but now Z value is reduced to R. So now in the case of resonance, Z value is how much? Minimum. Okay, so if Z is minimum means the resistance is minimum. If Z is minimum, then current would be minimum or maximum? Then the current would be maximum. Okay, obviously according to Ohm's law, V is equal to I multiplied by R. If current increases, then resistance, if resistance decreases, then current increases, right? So if Z is minimum, the current would be maximum. So they won't say like this that this is the condition of resonance. They can indirectly say that you are having maximum current. So in that case, you should understood automatically that if the current is maximum, then impedance is what? Minimum, right? And if the current is maximum, for that we are having which condition? For that we are having condition for resonance. Clear? They can say any one condition. They can say that XL is equal to XC, then we'll understood that this is the condition for resonance. They can say Z is minimum, they can say current is maximum. Okay, they can say resonance also. They can say that if current is maximum, then we need to understood that this would be the condition of resonance. Clear? Now we'll need to draw the graph. On this graph we'll draw, on the x-axis there is a frequency. Okay, now we have to draw the graph for the XL. As you know that XL formula, XL the formula is how much? Omega L, or we can write down XL is equal to 2 pi FL. So tell me, what is the relationship between the XL and the frequency? Directly proportional or inversely proportional? Directly proportional. XL is directly proportional to frequency. So for directly proportional, the graph is always a straight line. Okay, the graph is always a straight line. Like remember, you have studied Ohm's law that V is here, current is here, then you will draw a graph like this is a straight line. Okay, now in this graph only we'll draw XC. XC is how much? That is 1 by omega C. So we can conclude that XC is inversely proportional to frequency. Correct? So for inversely proportional relationship, we'll draw the graph on the negative side. Why I'm drawing this graph on the negative side? Remember, you have studied that Z is equal to R plus JXL. For the XL value, we'll use positive, and we have studied that is R minus JXC, XC for the negative, right? XC for the negative. So that's why I'm drawing the graph for the negative side. Okay, any doubt up to here? This is the graph for the XL and this is the graph for the XC. Clear? Now we need to draw the graph approximate reactance, means we can say the net reactance. Net reactance is approximately equal to XL minus XC. If XL is greater than we'll take XL minus XC. If XC is greater than we'll take XC minus XL. Correct? So similarly we'll draw a graph for X, means the total reactance. If it is for XC, draw a curved line like this. If it is for XL, draw it a straight line as the XL. For XC it is a curve like just like the XC. For XL it is a curve. So this is the value for the total reactance, that is approximately equal to XL minus XC. And wherever it cut at the frequency, that is the resonant frequency. We got it from this approximate reactance. Okay, clear this thing? Any doubt up to here? Now we need to draw Z. As you know that in the case of impedance, impedance is equal to R, that is Z is equal to R in case of resonance. So what does we conclude that? Z is independent of frequency. Correct? Z is independent of frequency. It does not depend on the frequency. So we can, for if it does not depend on the frequency, then the graph would be like a straight line, right? What does it show? What does it show? It shows that if you will increase the value of frequency, the value of impedance would be same. Suppose it is 5 ohm. So for all the values of frequency, Z is equal to R only, that is same value. Z value is not changing with respect to the frequency, because in this formula we are not having frequency, so Z is equal to R only. Okay, understood? Clear? Now in the next case, we need to draw that minimum impedance. I told you, at the condition of resonance, only at the condition of the resonance, Z is what? Minimum, means before resonance it is maximum and after resonance it is also maximum. This is minimum only for the condition for resonance. What does it mean? That if there is no resonance, then in that case impedance would not be minimum, right or not? So At this is the particular resonant frequency. Correct, this is particular resonant frequency. So at this resonant frequency, impedance is minimum is this one. So before resonant frequency it is maximum, and after resonant frequency also it is maximum. So this one is Z. Okay, so at this particular resonant frequency, Z is equal to R we have shown, but before resonance I am showing it is increasing exponentially, and after resonance also, after resonant frequency also it is increasing. Understood? Now I told you one more thing, that if impedance is minimum, then current would be maximum, again at the condition of what? Resonance, right? If current is maximum at the condition of resonance, means before resonance it is minimum, and after resonance it is also minimum. So I am drawing the graph for the current now. Suppose for the current we are having at this particular resonant frequency, current is maximum, before it is minimum, and after it is minimum. So this is the graph for the current. This is technically known as series resonance curve. Okay, you can write down it. This is known as series resonance curve. This is the graph. Whenever they'll say that describe the series resonance, you need to draw this graph, or characteristics you can say, by your own. Understood?